Hello, class. Well, today we're going to be talking about the introduction to proofs. And really, when you're trying to prove things in math, the only thing that matters is really what you can, well, prove. Proofs have a basic structure, okay? You're going to have some things that are called givens, okay? And just like they sound like, givens are simply what you're given. So you may be given A, okay, and that may be things like some angles or some line segment lengths or some be told that some things are congruent, and you need to prove, okay, you're going to prove B, and you're going to use a logical series of steps to go through that, and you're going to start at A, and you're going to go through a bunch of steps, and you're going to end at B, okay. Basic proofs look something like this, okay. Typically you have two columns here. You have statements here. Yep, that is your shirt there. Okay, you're going to have a statement here, and then you're going to have a reason here. Okay, and kind of like a good story, things will be numbered 1, 2, 3, 4, 5, 6, like this. Okay, and kind of like a good story, you're going to start off the first couple things. Okay, these are probably going to be your givens. You're going to state your givens, get those right on the board. Then you're going to have a second section here where you're going to have logical steps. Okay, logical steps in proving what you want. And finally, you're going to end up here with your conclusion. Okay, your conclusion should be your proof step. Okay. Okay, so your conclusion here should be this. Okay, just about every time. Okay, when you're doing these proofs, remember, do not assume, A-S-S-U-M-E, anything. You must have a reason. Okay? You must have a reason. Now, for this next series of remember steps, I thought about making you write these out, but decided against it. You're going to number each step. Make sure you number each step as you're going down through the proof. Start with the given information. Okay? This could be, AB, okay, is congruent to CD, whatever you're given, start with that. That should be your first couple of steps. Statements with the same reason can be combined into one step, okay? So if you want to state both maybe you have this, and maybe you have angle A is congruent to angle D, okay? Maybe you're given both of those, so you'd have those two steps in one step, and you'd say given, okay? So you also want to draw a picture and mark it with the given information. Most times you'll be given a picture, sometimes you have to sketch it, but make sure you mark it. Okay, remember, you're going to use hash marks for line segments, something like this and this, to show those two line segments are congruent. If you've got angles, you've got markings like this, okay, to show those angles are congruent. You must have a reason for every statement, okay, and reasons, okay, down here, if you follow right down here, reasons are going to be definitions, definition of congruence, definition of a right angle, definition of perpendicular lines, things like that. Postulates, properties, and previously proven theorems. You're going to be able to use some notes on your test. Okay? I'm going to give you a series of things you can use for your proofs, but in your reason columns, you're going to have these kind of things here. The order of the statements in the proof is not always fixed, but make sure the order makes logical sense. Okay? We may have two different proofs that prove the same thing correctly, and I may have something as step one, that's step one, because step one is probably going to be your givens. But I may have step 3 as CP, CTC, okay? And you may have that as step 4, okay? Doesn't really matter as long as you get to the same ending, as long as it makes sense, okay? Makes sense, okay? The only time you're going to use given, okay, the only time you're going to use given for anything is going to be, okay, this given statement here is if you're given the information. Okay, that's the only time you use given as the reason. You can use symbols and abbreviations for words within the proofs. Okay, for example, you can use this for congruent. Okay, you can also use this for angle. Use the symbology that we've been talking about all year just to make your life a little bit easier. Let's take a look at a couple examples. Okay, for here in example 1. Okay, example 1. I have this sketch right here. Here's our sketch. Okay, and I'm given that angle 2 is congruent to angle 3. So that's going to tell me angle 2 here, pardon that scratching, that's my dog wanting to go out, is congruent to angle 3. Okay, so I can say that 2 is congruent to 3. And what it wants me to prove is that angle 1 up here is congruent to angle 4. So they gave us the steps here, 1, 2, 3, 4. We're going to fill in some reasons just so we get used to it. So, for instance, for our first step, angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. Well, yeah, angle 1 here, congruent to angle 2. We know what those are. We talked about those. Those are vertical angles. So it'd be vertical angles. Angles are congruent. Okay? Now, step 2. Angle 2 is congruent to angle 3. Well, this step right here came from our given. Okay? So for step 2, I'm simply going to write given. Okay? Step 3. Angle 3 is congruent to angle 4. Okay, right here it's saying 3 and 4 are congruent. Well, again, that's going to be vertical angles are congruent. I probably could have put this right up here. Okay, I could have gone right here. 1 is congruent to 2. And angle 3 is congruent to angle 4. Okay, again, because it's going to be vertical angles. I'm going to abbreviate vertical there. Are congruent. Okay, lastly, it wants to say that 1 then is congruent to 4. Well, what we've proven here, we've said that essentially 1 is congruent to 2, 2 is congruent to 3, 3 is congruent to 4. Okay, well, that's simply going to be the transitive property. Okay, transitive property. Transitive property right there. Okay, remember that we said that if A equals B and B equals C, then A equals C? Same idea. 1 is congruent to 2, 2 is congruent to 3, 3 is congruent to 4, therefore 1 is congruent to 4, transitive property. There you go, okay? This is what we were looking for, okay? That shows up right down here as our last step. That's our proof. We just proved that angle 1 is congruent to angle 4. Okay, in our next example, this time we're given AC is equal to BD, and we want to prove that AB equals CD. Now this is interesting because here we don't have any congruence, we have equals. So we're talking about measures. We're talking about measurements. So because of measurements, we can add things and subtract things. These are taking the place of numbers, okay? AC would be a number. BD would be a number, okay? So really we're saying that this is the same as this. Okay? These aren't traditional methods, but that's what we're talking about. And we want to prove that AB equals CD. Well, start off. AC equals BD. Well, this bad boy right here, that's our given. See, there it is. So we're going to say that is given. Okay, now AC equals AB plus BC. Okay, so AC equals AB plus BC. Well, that is, and we also have here that BD equals BC plus CD. Okay, well, that is the segment addition postulate. Segment addition. Okay, should have gotten that when we did the list of tools for doing proofs. Okay, so now we have AB plus BC. Okay, this. Okay, talking about this thing equal to BC plus CD. Okay, well, that's simply going to be substitution. Okay, substitution. Sorry, I'm having trouble with my eyes tonight. Substitution. Okay, because what they did was essentially say, well, I'm going to take out AC. Okay, from here, I'm going to put in AB plus BC. And I'm going to take out BD here, and I'm going to put in BC plus CD. So I have this equal to that. So I have substitution. Then this one's pretty slick, okay? Because these are all numbers, remember, you can subtract. So if I were to subtract BC from both sides here, okay, like it's an equation, okay, if we were solving equations there, those cancel out, leaving me with AB equals CD. So that's going to be the subtraction. This one's back from algebra. Subtraction, property of equality. Subtraction, T-R-A-C-T-I-O-N, property of equality. Okay, so we start off with our given. We use segment addition to bring this in, and then substitution and subtraction, property of equality. Okay. Now there are probably other ways of doing this. You could have used BC in there somehow and said that used the reflexive property or gone congruent on some of these, but you get the idea. Okay. You started off with your givens and you got your proven. Let's take a look at our last example. Okay, last example here. I want to go through, I want to prove, given that measure of angle 1 equals measure of angle 2, and measure angle 3 equals measure of angle 4. I'm going to go ahead and mark these in our sketch here, in our drawing. I've got 1 and 2 having equal measures, and 3, get out of there, 3 and 4 having equal measures. Okay, remember 2 hash marks is different than 1 hash mark. So I'm going to start off with my given, step 1. I'm going to say measure of angle 1 equals measure angle 2. I'm going to say measure angle 3 equals measure angle 4. And that's going to be given. Okay. Step 2. Okay. I'm going to say that my measure of angle ABC is going to equal my measure of angle 1 plus my measure angle 3. And I'm also say measure of angle DEF equals measure of angle 2 and measure angle plus measure angle 4. Measure angle 2 plus measure angle 4. Okay? This step is going to be the angle addition postulate. Okay? Angle addition postulate. Okay, you probably hear my daughter in the background. She's cute. Okay. Next, step 3. We're going to say, okay, so for step 3 here, what I'm going to want to say is, well, I've got ABC, this measurement, equal to 1 and 3, angle 1 plus angle 3, and DEF equal to 2 and 4. Okay, I got those here. I also said that 1 and 2 is equal to 3 and 4. So here's what I'm going to do. I'm going to do this. I'm going to say measurement, angle 2, let's go measurement angle 1 rather, plus measurement angle 3 equals measurement angle 2 plus measurement angle 4. Okay, and that's going to be because I added. Essentially, it's kind of like I took this and I added it to that, and this and I add, and 2 and I added it to 4. So angle 1 added to angle 3, angle 2 plus angle 4. Okay, because I did addition, my reason here is going to be addition property of equality. Addition, I'm just going to call it P-O-E. Addition property of equality. Okay, and finally, step 4. Okay, because I have proven that this, okay, equals this up above, and I also proved that, change colors here, this, how about that yellow, okay, equal this, okay, I'm going to go ahead and say now, I'm going to change colors again here, that, then that measurement, whoop, leave my pencil here, that measurement, sorry, I'm writing in white there, can't help that. Let's try that. There we go. Measurement ABC. Measurement angle ABC is going to be equal to measurement angle DEF. I'm going to put down here substitution. Okay. STI substitution TIO. And excuse me, a little sneeze there. Okay, so that should do it. That should do it. Okay, these get a little complicated. We're going to be spending a lot of time in class on these. I hope you get it. Okay, I hope this helps. We're going to work on these. Remember, follow the steps, use logical thinking process, and you should be okay in the end. Okay, you should be okay in the end. So anyway, The magic word for this video is going to be spoon. S-P-O-O-N, spoon. Okay, I will see you in class. Thank you.